This is the second part of our video sequence for today's worksheet, and this part's going to deal with finding the number and the type of solutions you get for a quadratic equation. And when I say number, I'm talking, do you get any solutions? Do you get one solution? Do you get two solutions? And when I say type, I'm wondering if they are complex numbers where you have a real or an imaginary part, whether you have just real solutions. Those are the types of things that I mean when I'm looking for number and types of solutions. So up to this point, when we've been solving our equations, we've had answers that have looked like this. Right, and I know that if I have a plus and a minus, what that really means is I have two solutions, 3 plus 7i and 3 minus 7i. I know these solutions are complex. Two complex solutions. And why do I know they're complex? Because I have both a real part and an imaginary part. Okay, this number is not real, it's not imaginary, it's real and imaginary, so it's called complex. I've also gotten problems like that had solutions, similar to this, where I have two solutions again, and they're both real solutions, right? I can find a half and I can find -1 on the number line. And then I've also had problems that looked like this, where I've gotten one solution and it's one real solution. Okay, it's really handy to know what kind of solutions you're going to get when you're looking at word problems, because in real life, if you come up with an answer that's a complex solution, typically those solutions don't count, right? We cross those off because I can't have a complex solution as the length of a side of a triangle. Okay, I also, it's nice also to know with word problems how many solutions you get so that you know how to find what it is they're asking for. So I know when I look at a quadratic equation that we've used the quadratic formula right here. I have it right here. This is not a quadratic equation, it's a formula. It's called the quadratic formula. We use this to find solutions, or we can use this to find solutions of quadratic equations. Well, when it really comes right down to it and we're looking to see whether we're going to have real numbers or imaginary or complex solutions, what tells us whether we're going to have a real or a complex? Well, it's the part underneath the radical. If the part under the radical, if b squared minus 4ac is positive, then my solution is going to be real, right? Because I can take the square root of a positive number and find that on my number line. But if what this evaluates out to is negative, well, now that changes everything, because I know when I take the square root of a negative number, that is no longer a real number, that's imaginary. So that gives me my imaginary part, so my solution is complex, but not real. Okay, so if b squared minus 4ac is positive, I actually get two real solutions. If b squared minus 4ac is negative, I get two complex solutions. And why do I get two? Because I add and I subtract. But how do I only get one solution? Because we've gotten one solution, like in this case right here. Well, there's another number that's not positive or negative. It's right in between positive and negative numbers. What happens, and we've had this happen before, where b squared minus 4ac turned out to be 0. If that's 0, negative b over 2a is a real number, so we get one real solution. So we're going to use what's under the radical. What's under the radical has a name. It's called the discriminant. we're going to use the discriminant and evaluate it. So we still need to find a, b, and c. Our equation still needs to be in standard equation form. Okay, we're only going to evaluate b squared minus 4ac because we're not finding the solutions. We're going to find how many solutions we get and the types of the solutions that we get. So we get, if b squared minus 4ac is positive, we're going to get 2 real solutions. If it's negative, we get 2 complex but not real solutions. And if it's 0, we only get 1 real solution. So here's an equation. We're going to find a, b, and c first. So if my equation is supposed to look like this in standard form, I can see that a is going to be 1, b is going to be 8, and c is going to be 16. So now let's go ahead and evaluate the discriminant. And the discriminant is the part that's under my square root in my quadratic formula. So what does this equal? Well, if I put in an 8 here and square it, and remember, please substitute using parentheses. A is 1 and c is 16. What do I get? 8 squared is 64 minus 4 times 1 is 4 times 16 is 64. My discriminant turns out to be 0. So what does that mean for the solutions to this equation? Well, we have, according to our chart up here, if the discriminant is 0, we end up with 1 real solution. So we will have 1 real solution. Okay, so we're not solving, we're just finding out how many and what type of solutions we'll get. So how about for this one? Are we in standard equation form? And it looks like we are. So let's find a, b, and c. A looks like it's 1, b is going to be 3, and c is going to be 7. And remember, our discriminant is b squared minus 4ac. So we're going to substitute our values in. So b is 3, a is 1, and c is 7. So when we evaluate that, 3 squared is 9 minus 4 times 1 is 4 times 7 is 28. And when I subtract 28 from 9, I get a negative 19. Okay, if I go back up here and look at my chart, a negative discriminant gives me 2 complex but not real solutions. So I get 2 complex but not real. Why do we have to say but not real? I don't know if you guys remember, but when we were talking about our complex numbers, in our complex numbers we have pure real and pure imaginary numbers. We want to disclude, we don't get pure imaginary numbers here. Well, sometimes we might. Maybe. I have to think about that. Yeah, maybe we do. Sometimes we get pure imaginary numbers, but we get, imaginary numbers are also considered complex, even though they don't really have a real part. But our real numbers are complex numbers, and so we want to make sure that we don't say complex without saying but not real, because we want to disclude the fact that we want to disclude any just pure real numbers. So here, for our next example, this doesn't look anything like the standard form of our equation. So we're going to have to be moving things around. So I know I have a negative 7x squared. I know I have a positive 7. But now I have these other guys on the other side. So I think I need to add the 7x to both sides. And I need to subtract the 3 from both sides. So now I have 0 on this side. 7 minus 3 is a positive 4, plus 7x minus 7. I'm sorry, I should have written an x squared there. Okay, so now I have it in standard form. So now let's find A, B, and C. A is -7, B is 7, and C is 4. So my discriminant, again, discriminant is B squared minus 4AC. So when I substitute using parentheses, I get this. Now let's go ahead and multiply that out. 7 squared is 49 minus, okay, 4 times -7 is -28 times 4. That's going to be a -112. And I know that a negative times a negative is a positive. So I end up with 11, 5, 6, 161, which is a positive number. So what does that tell me in my table up here? That tells me I have 2 real solutions. Okay, both of my solutions I can find on a number line. 2 real solutions. All right, my last problem that I'm going to do here is this one. Again, this one doesn't really look anything like the standard form of my equation. Terms are mixed up and nothing's in the right order, and then I have this 3x on this one side. So I have a positive 4x squared, and I have a positive 7. This has to be moved to the other side because my equation needs to equal 0. So I end up with 4x squared minus 3x plus 7 equals 0. So now I'm ready to find A, B, and C, and I notice A is 4, B is -3, and C is 7. So when I plug that into my discriminant, which is B squared minus 4AC, I'm going to use parentheses. -3 squared minus 4 times 7. What's -3 times -3? I know a negative times a negative is a positive, and 3 times 3 is 9. Okay, so what's 4 times 4 is 16. 16 times 7 is, let's see, let me give myself a visual. 70 and 42 is 112. So when I subtract, I'm going to get -103. So we've already done one that has a negative. I know that means I'm going to have 2 solutions. And since this is the part that's under the radical, if I take the square root of a negative number, I get an imaginary solution. So I'm going to have 2 complex but not real solutions.